Bacteria are living organisms that have some certain awesome features, specifically multiplying itself. And one of the most important and accurate models generating its population is the exponential models, if we're talking mathematically. Well, there are two models of exponentials. There's the exponential decay and the exponential growth. But let's focus first on the exponential growth. An exponential growth is an increase in number of population or amount at a constant rate. But how to do it? So, for step 1, we need to recall the formula. Remember, an exponential equation in general, we write that as y is equal to a times the quantity 1 plus r raised to t. The next one, we need to know the variables. In this equation, we can see that we have a, r, and t as variables in this equation. Now, a is the initial amount or the initial population in this initial amount and initial population, this is where we start. For example, the initial amount of peso or the initial population of the people. Next, the R or the growth rate. The last one is the T or time. Sometimes we use X for this formula, but we will use T for this time. And remember, this variable A and R must be greater than 0. And that is for this to be an exponential function. Now that we know the formula and its variables, let's have an example. So for the first example, we're going to try growth by doubling my bacteria. And suppose we have one bacteria, which can double every R. By the end of the day, how many bacteria will there be? So here is our bacteria. It can double in just an R. 1 R. And another R, it doubles again. So this is for 2 R's. So it's going to be hard to know that we're going to solve it for just 24 R's and we're going to count them all. So we're going to use the formula. Raise. And so, okay, the formula. The formula will be y is equal to a times 1 plus r raised to t. Y the future value, a the initial value, 1 plus rate. Rate is the growth rate, and t for the time. Y is unknown, so we leave it blank. A, the initial amount, is 1 times 1 plus the rate, which is 1 also, raised to the time, which is 24 hours. So, we need to add these two. 1 plus 1 is 2, raised to the 24th, and multiply it by 1. Well, for some people, they multiply this first and then raising it to 24. We shouldn't do that because the answer will be different. We need to first get the exponent or get the value of this and follow the PEMDAS rule. After raising it to 24, we need to multiply it to 1. So 2 raised to 24 is equivalent to 16,777,216 times 1. So y is equal to 16,777,216 bacteria. That's a lot of bacteria in just one day. Linden owns a chain of fast food restaurants that opened 200 stores in 1999. If the rate of increase is 8% annually, how many stores does the restaurant operate in 2007? So in this problem, we're going to find the future number of stores in the year 2007. So y is still unknown. So we're going to use the formula. Y is equal to A times 1 plus R raised to T. Y is unknown. A, or the initial amount or value, is 200. 200. The rate of increase is 8%. 8%, change it to decimal value, will be 0.08. And the time will be the gap between 1999 and 2007. So we need to subtract 2007 from 1999. So that will be 8 years. So the time will be 8. So after getting the values, we put this into the formula. Y is equal to A, 200, and 1 plus R, 0.08 raised to 8. 1 plus 0.08 is 1.08 raised to 8 times 200. And then again, don't multiply this 2, just raise this first. Raise this first before multiplying to 200. So 1.08 raised to 8 is 1.85. 1.85 times 200 is 370. So that will be 370 stores in the year 2007.
That's right.
In the year 2000, the population of the town Alibaf is 10,000 people. Since then, the population has increased at a constant rate of 18% each year. Assuming this rate of increase is constant, what would the population of town Alibaf be in 2020? So, if you think you're confident enough to answer this, you can pause the video and answer it by yourself. Well, as you can see, Y again is missing. So we're going to write the formula down. And know the variables one by one. So y is unknown. A, the initial amount is, or the initial population is 10,000 people. So I'll write 10,000 in here. So 1 is constant, plus R, the rate of 18%. 18% or 0.18. So we need to place the decimal value in here. Raised to t, the time. So what's the time? The time we'll be getting from is the year from these two, the year between the gaps of these two. So 2020 minus 2000 is equal to 20. So the time will be 20. So 1 plus 0.18 raised to 20 times 10,000. 1 plus 0.18 is 1.18 raised to 20 and multiply it to 10,000. So 1.18 raised to 20 is equal to 27.39. And multiply it to 10,000. If you multiply this to y will be equal to, this should be y, not a. I'm sorry. Y. 10,000 times 27.39 equal to 273,900 people by the year 2020. Well, I want to know also what will be the population in the year 2016. So, let's try it. Let's change this to 2016. So, in the year 2016, Y is still unknown. A, or the initial population or amount, is still 10,000. And R will be still 0.18, but the time will be changed. So we need to subtract these 2 years. 2016 minus 2000 is equal to 16. So we need to put these values into this formula. Y is equal to A times 1 plus R raised to T. So Y is equal to A, 10,000 times 1 plus 0.18, which is the R, and raised to 16. 1 plus 0.18 is 1.18 raised to 16 times 10,000. 1.18 raised to 16 is 14.13. And 14.13 times 10,000, the future value will be 141,290. So the population in 2016 in the town Alabaf is 141,290 people. And that's all. Thank you.